And how voltage and current are related in a capacitor. Yeah, let's say that voltage across a capacitor is 5 volts, and capacitance of a capacitor is 1 millifarad. What current flows through this capacitor? 0. Very good. How did you get it? Because we have to take the derivative of voltage, correct? Because current flowing through the capacitor is equal to the rate at which charge on the capacitor varies. Right? And if we keep constant voltage across the capacitor, charge on the capacitor is going to be constant as well. All right. So this time I will start actually not from the current but from the voltage, because that way I will calculate derivatives rather than integrals. So if I write now voltage at instant t to be equal peak value of the voltage times sine of angular frequency plus initial phase, how do I get current from that? What do I have to do to that? Differentiate it. Well, if I multiply it by C, I will get charge, and now I have to differentiate it. All right, so if I differentiate now this function, it's again composite function. External function is trigonometric function, internal function is linear function. After integration, I will get this cosine function, and well, in order to determine the phase and peak value in principle, I want to have sine function. Well, cosine function is related to sine function by, they are just shifted. So I got this expression now. Current at instant t is equal to this number multiplied by sine of angular frequency plus this number. So what's the peak value of the current then? Omega c times Vm. All right, so angular frequency times capacitance times peak value of the voltage. So how about impedance? What is therefore impedance of a capacitor? Impedance of a capacitor, remember that impedance of a capacitor relates what with what? Something which will be useful here. Peak value of the voltage with peak value of the current, right? Impedance is equal peak value of the voltage divided by peak value of the current. Let's do it. This expression is equal to what? This is peak value of the current, so it should go to the numerator or the denominator? Denominator. What should be in the numerator? Vm, correct. So Vm and Vm cancels, and impedance of a capacitor, and impedance of the capacitor is 1 over angular frequency times capacitance. Now this number over here represents the initial phase of the current. So I see that initial phase of the current is equal to initial phase of the voltage plus pi over 2. What's the phase angle? Now make sure that you do not confuse what to subtract from what. So from the initial phase of the voltage, from delta V, we have to subtract initial phase of the current. So we need to subtract delta V plus pi over 2. Well, delta V and delta V will cancel, and we will be left with pi over 2. So phase angle is minus pi over 2. Did I say pi over 2? I think so. Yeah, so phase angle is minus pi over 2 this time, which means that, that the phase relationship is opposite to what happens in the inductor. This time, phase of the current happens earlier than phase of the voltage. Look that at this instant, phase of the current is pi over 2, but we have to wait quarter of a cycle for the voltage to get to that phase. We say that current leads the voltage by pi over 2, and voltage lags the current by pi over